Hello, everyone. Welcome to week 2 of the Quarantine Coding Academy series, R is for Actuaries. Today's lesson is data visualization with ggplot2 and plotly. First, some background. Let's go over a not-so-hypothetical scenario. You're asked by your stakeholders to do some analysis. You spend a lot of time in Excel and PowerPoint putting together this analysis and the accompanying presentation. After you present, your stakeholders ask to see the same analysis, but by different cuts. This seems like a simple request, but it actually involves rerunning the entire process. And this might happen several times in a project. With the tools we are learning in R, we will be able to greatly reduce this type of back and forth. Not only can R automate this iterative process, but it can enhance the ultimate deliverable. Last week, we looked at how dplyr can help with our data prep. Today, we will be focusing on 2 new packages for data visualization, ggplot2 and plotly. Ultimately, in lesson 4, Shiny will do an even better job of analyzing our data. Shiny is really just a wrapper around everything we are doing in lessons 1 through 3. So we need to learn these extremely useful basics, even outside of Shiny first. Graphs created with ggplot2 generally use this form. This is your base ggplot2 graph. Let's deconstruct this line. There's 2 components. There's the ggplot object and your geometry. For this lesson, the ggplot object will always contain the 2 arguments listed, data and aesthetics. All the graphs we look at today will have at least an X and a Y aesthetic defined, and maybe more. We add the geometry layer using a plus sign, and that's similar to how we use the piping operator with dplyr in lesson 1. We can add additional layers on top of this with additional plus signs as needed. Later on, we will demonstrate with facets, labels, and titles. The generic XXX in this line, this denotes your graph type. So if we set it as GM point, we'll have a scatter plot. If instead this is GM bar, we'll have a bar graph. Or if we use GM line here, this is a line graph. Today, we will only look at these 3 graph types, but there are several others, box plots, density plots, heat maps, and a lot more. All the graph types follow this same general structure here. If we use object-oriented programming approach, we can make our iterations easier with ggplot. To explain, you create your ggplot object and you give it a name, and the ggplot object is created using the ggplot function, the data argument, and the X and Y aesthetics. Then once you create this underlying ggplot object, you quickly iterate through your graph types just by adding your different geometries on top of the same underlying ggplot object. Now all this will make more sense with some examples, so let's begin our script. In week 1, you were given some homework. You were asked to group our data set by specific cohorts. This week, we will visualize these results. A sample solution along with additional supporting files can be found linked in the comments section below. Summarizing what our week 1 homework requests were, task 1, calculate actual to expected mortality rates by banded age. Task 2, calculate actual to expected mortality rates by banded age by gender. Task 3, calculate actual to expected mortality rates by banded age, by gender, by smoker status. And this was to be done, all 3 tasks, for all 5 mortality tables on both a count and a dollar weighted basis. I have a sample solution here that also includes a task 4, which we will discuss at the end of this lesson. In that task, I calculated actual to expected mortality rates by banded age, by gender, by smoker status, and by preferred status. Here's a snippet of code that accomplishes these 4 tasks. All these tasks were accomplished using the functions that we went over last week. I did use one new dplyr function, summarize at. I found it was simpler to use than the summarize function I showed you last week when we're using multiple columns like we did in our homework. I found that function using Google. I hadn't used it before doing my homework. So just if you find that it's a little bit challenging to accomplish something, Google's a great help. For today, we're going to focus on the 7580D actual to expected cohort. And what this is a dollar weighted actual to expected using the 7580E table. I selected this cohort arbitrarily because the focus today is just to demonstrate various graphs. We could easily change our explanatory variable within these graphs just by changing the column in the appropriate aesthetic. For next week's lesson, we will look more closely at the relationship among these 10 actual to expected calculation methodologies. And this will be an opportunity to look at the dplyr function gather, which is very useful in the data visualizations with ggplot, but we're not going to cover that this week. The snippet above was saved as week2.r, which is available in the comment section. So I saved my version here. You save it to with your data in your that'll be your working directory. So when you open up your script, set your working directory to your source file location like we did last week. And the first thing we'll do is we'll run the homework plus task 4. Data prep for task 4. So you see it's running. Once it's done, we've grouped our data and we've created the objects that we're going to visualize in later tasks today. So next, let's start a visualization, and we'll start by looking at our target variable by a single explanatory variable. So this is a very common and simple request, and we have an example from last week's homework. Task 1, you were asked to look at actual to expected mortality rates by banded age. So this is a very simple relationship, and the simple relationship means it's a good starting point for ggplot2, so it's not too overwhelming, even if the graphs are a little bit boring. Like I said, a good starting point. So the first step, like we went over before, but now with an example, it might make a little bit more sense, and it hopefully will each time we go through this. First step, create your ggplot object for this exercise. So we do that with this snippet of code. Note, we have an additional aesthetic on top of the X and Y that we mentioned earlier. That's group equals 1. We need that for our whenever we have a single explanatory variable. So here we have X is set to our explanatory variable, banded age. Y is set to our target variable, actual to expected. And once we have this ggplot object created, like we described above, it's very easy just to add your different geometries and iterate through different graph types. So we create a scatter plot, a line graph, a bar graph, and a combination of a scatter and a line graph, all by just adding layers to your underlying ggplot object. Some things to point out, notice the additional argument stat equals identity, which is something that you need when you're creating bar graphs. It's the only argument you need with a single explanatory variable. We're creating 4 different graphs using 3 different geometries, but they're all on the same ggplot object. So they're all just different ways of visualizing that same underlying X and Y relationship from the designated data set. Now there's 4 graphs for 3 geometries because we add this additional graph where we add the line graph, a line graph on top of our point graph to just start to demonstrate a little bit of layering. So once you create these graphing objects, it's very easy to call them just by typing out the in R, just typing out the name of the object. So we've demonstrated that here. Here's your scatter plot. Here's our bar graph. Here's our line graph. And here's our scatter line graph combo. When we run this code in our R script, it demonstrates how graphing is rendered in RStudio, which is a really nice feature of RStudio. So let's go to the script. Let's go through just our task 1 code, which I've saved here. So first you create your ggplot object. And you see that just like any other object, it just shows up in the top right with our data frames and group data sets and all sorts of different object types, but they're all objects. Now we're going to create our graph objects, which will also show up here. Scatter plot object, line graph object, bar graph object, scatter line graph object. So we've created them. Let's look at them. So first the scatter graph. When you run it, this is where we see the bottom right console, which we haven't used before with RStudio. It very nicely renders our graphs instantaneously. And if you want to see it closer, you can click on the zoom button here and it opens in its own window. So you can look at it more closely. It's a very convenient and simple feature with RStudio. And now you can just iterate through the different object types just by calling them, the different graphing objects just by calling them. So it's really nice. Next, let's look at our target variable by 2 explanatory variables. We did this with task 2 from our homework. Look at actual to expected mortality rate by banded age by gender. So just like we've shown this entire lesson, our first step, create our ggplot object. And there's several ways we could add this extra explanatory variable on top of what we created in task 1. For our particular example, we're going to use the color and fill aesthetic in the ggplot object. So what we have in this ggplot object is we have X is banded age, which is our first explanatory variable. Y is our actual to expected ratio, which is our target variable. And color and fill are both set to gender, which is our new second explanatory variable. Then once you build your ggplot object, the very familiar next step, just iterate through your graphs by adding various geometries to it. As we do here, geometries just added to the same underlying ggplot object which we had just created. Some things to point out. Notice we have additional bar graphs, so 3 bar graphs now. And these are all differentiated. We still have the stat equals identity argument, but now we add the position argument, which is what differentiates each of the 3. So if position equals stack, you're creating a stacked bar graph, which is to focus on total volume. If your position equals fill, you have a 100% stacked bar graph, which focuses on the mix among levels. And if position equals dodge, you have side-by-side bars, which focuses on comparing levels. Hard to keep those straight sometimes, so the nice thing about R, how it's so easy to iterate through, you can just trial and error and see what fits your use case. And as you use it more, you'll get more familiar and it'll be easier. So again, just calling these objects to look at the graphs, you see now that we added these extra dimensions, which is the color and of the color and the fill of the aesthetic, and that differentiates what our gender is. So now we can compare male and female actual to expected by banded age. It's really clear with this bar graph, not so clear with this stacked bar graph. I'm sorry, really clear with this line graph. Not so clear with this fill bar graph or this stacked bar graph or the 100% stacked bar graph. A little bit clearer in this side-by-side, the dodge bar graph. Maybe not your first choice, but it's better than the other 2 types of bar graphs. And then the scatter line graph is the one I like best. I think this gives the best visualization of the comparison between these 2 actual to expected series. Now, choosing which geometry is right for your use case comes down to several subjective factors. What do you currently use in your company? And probably most important, what does your boss like? But there's some general rules for which types of plots are best for combinations of different variable types, like numerical versus a categorical versus numerical versus a categorical versus categorical. And it's good to understand the reasoning behind these rules. or the flexibility of R makes it possible to quickly iterate through several chart types, so you can find what best fits your particular use case that way as well. Now, I'll demonstrate the task 2 code in the R script here. So in this code, it's just very familiar. Create your ggplot object. Create objects with your different geometries added, and you see these all showing up in our list of objects. And then you just call the ones you want to see. And again, the one that I think looks best is this scattered line graph. This may not be the one that you like best, or there's maybe other ones that we haven't even covered. But you know, this is an example. So next, let's look at target variable by 3 or even more explanatory variables. And so with ggplot, there's a very powerful layer you can add to look at an additional dimension or dimensions. It's called faceting. There's two versions of it, facet wrap and facet grid. We'll start with facet wrap. So task 3 from our homework, we looked at actual to expected mortality rates by banded age, by gender, by smoker. So to visualize this, as usual, first step, create our ggplot object. And you'll see this ggplot object looks very familiar. We didn't add any additional aesthetic, or there's no recognition of the new explanatory variable in our underlying ggplot object. That's because we're addressing this with facet wrap, which, as we alluded to earlier, is handled by adding through the additional, it's an additional layer we add. So to demonstrate, so we have our underlying ggplot object, graph.task3. Now we're adding our geometries like we have all the way up to this point. And here's what's different is we add another layer, the plus sign like we said, and this is facet wrap with the argument smoker. So smoker status, that's the column name for smoker status, and we're saying facet on this. So here's what that graph looks like. So what the graph does is it demonstrates facet wrap by smoker status. Like I said, it's in the argument here, and it results in a copy of your graph. So it's a copy of our scatter line graph, but for every level of smoker status. So this only reflects smoker status as non-smoker experience, smoker status is smoker experience, or smoker status is unknown experience, is unknown status. So every single data point in our file fits into one and only one of these facets. Next, facet grid. So facet grid, you have two arguments as your, two variables as your arguments. And this way we're able to add even an additional explanatory variable on top of facet grid. So that's why I ran task 4 in the very first part of this lesson, is to set us up for this demonstration. So we'll visualize this relationship. So as usual, we take our same, create our ggplot object first, and it looks no different than the last, than task 2 and task 3 did, because again, we're adding our explanatory variables now through additional layers instead of through additional aesthetics. So we add these additional layers. In particular, we add this facet grid, which takes in preferred status and smoker status. So here's the new variable we're looking at, is preferred status. And we're putting both of these in facet grid, and this is the chart that it results in. So we have facet grid, preferred by smoker. So the rows are the first variable, which is preferred. The rows are preferred status 0 or preferred status 1. Top row is all people that are not preferred. Bottom row, all people that are preferred. Columns represent the levels of the second variable, which is smoker status. So smoker status non-smoker in this column, smoker status smoker in this column, smoker status unknown in this column. The other thing to keep in mind is these levels interact on each other. So for instance, the top left facet in our example above consists of only policies that are both non-smoker and non-preferred. So here is non-smoker, so it's a non-smoker column, and non-preferred row. So the data that makes up this facet has to be both non-smoker and non-preferred. And again, just like with facet wrap, every single data point that we have fits into one and only one of these facets. If you notice, we also have a couple of additional layers that we added to our graph here. We use the argument xlab to create the x label, ylab to create the y label, and ggtitle to create the chart title. So it's very simple to iterate through simple base graphs and then add more layers as you move closer to production. So that's what part of why I waited till the very end to add the titles and the labels. You don't want those in graphs that you're just looking at for proof of concepts, and you know that proof of concept and you know it's not going to be your final graph. It's better to wait, and then once you get to a graph that you're going to include in a markdown document or a shiny dashboard, then you polish it up with these additional layers like label, like title, and you center it and do all of that. And you see that ultimately, when you finally do get to that point, it's very easy to add these additional layers just with your plus sign. X label is very straightforward. Y label, very straightforward. Title is. So very simple to work with. So let's look at task 3 in our R script. So again, first thing, just create your underlying ggplot object, add your geometries in the facet wrap, and then let's look at it. So you have the 3 facets here, and they're all represent the different levels of smoker status. And if we look at facet grid instead, we have smoker status and preferred status. And as you get to facet grid is where you really see the value of being able to look at this in a separate window. It starts to get a little bit crowded down, even though this is really nice and clean to look at, it's a little bit small. So when you start to get in maybe more facets, you want to look in more detail, this is where it comes in really handy to zoom it and see a little bit larger and really to see the relationships. And then you can change which ones are facets, which ones are aesthetics to get to tease out the particular relationship that you're looking to examine. So that's what we were going to cover in ggplot2 today. Our next library or our next package is Plotly. And it's very simple to use Plotly in conjunction with ggplot graphs. All you have to do is add this wrapper around your graphing object when you call it. So you interpret this as render with Plotly this ggplot graph object. And by just adding this partial line, you get a lot of powerful functionality. You get tooltips, you get very basic interaction, you get additional functionality that I'll show you. So it's really, really powerful, and it doesn't even take an extra line of code. So for me, this is my default method of presenting graphs. I don't just type the graph object, I always put ggplotly around it. And I'll demonstrate here below all the graphs that we created this week, first with Plotly and then without Plotly. So, we saw these graphs that we called just by typing the name of the graph. And so the one that I've kind of focused on today is this scatter line. So you see scatter line 2, and that's how it's called. And it's just called by typing out the name of the graphing object. Very simple, and that's how objects work. But you can see the relationship, you can't see absolute values, you can't see how close they're getting. And if you had a lot of these lines, you could see how it might get messy. Well, let's look at the Plotly version of this graph. So below, I just called the same graphs and added the ggplotly argument around it. If we go to the scatter line 2 graph, so exact same syntax, scatter line 2, but we just put this wrapper around it, and now look at what what additional functionality we have. You hover over it, and you have tooltips, and you can see the 2 values to tell. Okay, not only is male higher, but it's A to E is 151.6 and females is 115.9. And you can, if there were a lot of lines, this is something else, you can look at just one of the lines if you want, or both of them. And as you get a lot of different groups, that becomes very handy. And this is just by adding this extra wrapper around it. There's some other functionality up here that you can use. So for instance, if I want to look at, instead of just getting this value, I want to see how they all compare. You click on these double lines here, And when you hover, you see it. Now I can very quickly see 151 to 115, 225 to 140, 252 to 240. So very powerful. You can zoom in on certain areas, zoom back out. And, you know, these are relatively simple graphs. As you start looking at very high dimension variables, you could very quickly see how this could come in handy very quickly and with just this simple line of code. So Plotly is a very powerful tool to use in conjunction with ggplot. I use it almost by default. So this lesson today was meant to serve as an introduction to data visualization in R. Now, the best graphs are often ones that offer stakeholders new insights into a business problem. And that often comes from applying innovative visualizations to existing problems. The graphic possibilities of R are nearly unlimited. And the more you explore its potential, the more effective you'll be at applying R to your actuarial tasks. We'll begin to explore more of this potential in this week's homework and in next week's lesson. So your homework, use only the 2015 table and using both count and dollar weighted ratios. Look at how mortality actual to expected rates are affected by the following: age basis, valuation year, gender, and face band. Use the same data set that we used for our weeks 1 and 2 lessons, the same mortality data set. Use any combination of aesthetics and geometries to visualize the relationship between these 4 explanatory variables and the target variable, the actual to expected rates. You should use the dplyr library for your data prep, and use the ggplot2 and plotly libraries for your data visualization. I recommend you use a combination of the geometries we went over in this week's lesson, and you should also use others that you discover on your own. So get your base feel for it using the geometries that we covered in this lesson, and also to help you sort of get the feel for how ggplot2 works. But then where you'll make your difference is Google and just start trying different types of geometries and see what gives you valuable insight into the relationships that we're looking at. What we're going to do is we're going to use these graphs along with your insights in next week's lesson, documenting your results with RMarkdown. A summary of all the graphs we created today can be found in the appendix below. Each graph is shown first without Plotly, then with Plotly. This HTML document, by the way, was created using only the packages we have covered in lesson 1 and 2, along with Markdown, which we'll cover next week. So these types of documents, including the embedded graphs with Plotly, will be something you will be able to create by the end of next week, just by adding one more package, one more simple skill set on top of what we've already learned in weeks 1 and 2. You'll be able to create this type of documentation, going from raw data to grouped data to visualization to documentation, all without leaving R. So that concludes week's 2 lesson, and I'll see you next week in our Markdown lesson.